Next, let's discuss another effect, the rate of change. If we know the rate of change of a function, we should solve its derivative. With the derivative, we can solve the differential of a function. We still use the graphs above to represent the relationship. For a constant a, what's its rate of change? We can choose 2 points. The first point is t0, and the second is t0 plus delta t. From t equals t0, the time changes delta t. You can find that for this constant function from t0 to 0 plus delta t, its value doesn't change. In other words, the time rate of change is 0. So we know the time rate of change of a constant is 0. We use the prime to represent the rate of change, which is also called the derivative of the time. Next, let's discuss the rate of change of v equals a times t. Similarly, the first point is t0. After a very short time, the second point is t0 plus delta t. The vertical axis of this point is a times t0, and the vertical axis of this point is a times t0 plus delta t. Then we know after this very short time, the change of this function's value is a times t0 plus delta t minus a times t0. It's a times delta t. Then we know from t0 to t0 plus delta t, the time changes delta t, and the function's value changes a times delta t. The time rate of change of v equals a times t equals a times delta t over delta t equals a. Next, let's discuss the time rate of change of the displacement s equals 1 over 2 times a times t squared. Similarly, we consider the time axis change from t0 to t0 plus delta t. Similarly, we know the vertical axis of this point is 1 over 2 times a times t0 squared. The vertical axis of this point is 1 over 2 times a times t0 plus delta t squared. It can be expanded as 1 over 2 times a times t0 squared plus a times t0 times delta t plus 1 over 2 times a times delta t squared. Then we calculate the rate of change. From t0 to the t0 plus delta t, the time changes delta t, and the rate of function's value is this. The time rate of change at t equals t0 is when delta t becomes smaller, this part becomes smaller too. When delta t tends to 0, this part tends to 0 too. t0 can be chosen at any point, then we know the derivative of 1 over 2 times a times t squared equals a times t. You may find from the discussion on the accumulated effect in the previous page, we know the integral of a is times t, and the integral of a times t is 1 over 2 times a times t squared. In this page, we know the derivative of 1 over 2 times a times t squared, that is the rate of change, is a times t. The derivative of a times t, that is the rate of change, is a. Now you can find that the accumulated effect and the rate of change, that is the integral and the derivative, are closely connected. Here are the derivative of some common functions. The derivative of t to the power of n equals n times t to the power of n minus 1. The derivative of sine t equals cosine t. The derivative of cosine t equals minus sine t. the derivative of e to the power of t still equals e to the power of t. You will learn the derivation of these conclusions in calculus course. We just list some conclusions here, and they are easy to remember.